Welcome to Immutable Infrastructure on Google Cloud. Our agenda for today covers disposable or immutable infrastructure, which is a major theme in the design of reliable cloud infrastructure. We'll first introduce these topics conceptually and describe what they are and what they try to achieve. Then we'll look at how we can implement these design patterns with instance templates and managed instance groups. Finally, we'll see a demonstration of these principles as we build a backend in Compute Engine by using custom images, templates, and instance groups. Let's get started. So, a lot of the best practices we will learn as cloud engineers will be based around the concept of disposable infrastructure. Let's explain what we mean by that. One of the metaphors that's often used to help illustrate the argument for disposable infrastructure is pets versus cattle, although it's a little bit of a blunt analogy. Pets are essentially individuals that you care for. They have names, usually cute names. You look after them for their entire lives because you care about them, and they develop their own personality and individuality. Importantly, you care for them when they're sick. By comparison, cattle don't have names. They're just a large group of animals, and they are more or less identical within that group. Essentially, they're a means to an end, which is one of the reasons I'm not a huge fan of this analogy. So let's quickly apply this to computers and IT. In the same way that we do want to care for a pet, we don't want to care for a server. Traditional servers, either physical or virtual, have a complete lifecycle that includes installing and configuring an operating system, managing updates and vulnerabilities, installing and configuring applications, resolving library issues and dependency problems, and troubleshooting and fixing issues. In a nutshell, if we're caring for individual servers, our approach will not scale. Once demand for our application outgrows the power of a single server, we're doubling our own workload. Now, this is a problem people have been trying to solve for a long time, which is why we have a plethora of different configuration management tools available to us. The problem is that the state of the server, with all of its different software packages, libraries, configuration options and dependencies, is too fragile, and it's liable to drift. Tools such as Puppet, Chef and Ansible can only do so much to attempt to imperatively tweak a server, command by command or interaction by interaction, back into a desired state. The eventual state of a server that has been running long enough will become something that cannot be reproduced precisely, which brings you back to your scaling problems. So ideally, we want to stop managing servers as individual, long-lived resources and start treating them as disposable and reusable components. We can do this by pre-building the desired state of our applications and configurations as machine images, and then using CI/CD tools to automate deployments. When we need to make a change to a running server, we don't actually modify the server in situ. We instead update our machine image and begin another automated deployment, thereby treating upgrades as brand new deployments of the latest image. If done successfully, this means that the lifetime of a server should never extend beyond the current iteration of its software and configuration. There are also additional benefits to this approach. Reusable and disposable components can be defined using infrastructure as code processes and tools such as Terraform. Infrastructure as code allows us to more easily collaborate with other engineers on our infrastructure using common software development processes, and at the same time it provides a living documentation of our systems. This also allows us to introduce automation, such as automating rolling updates to a group of resources. Combined, these practices provide far improved reliability over our traditional approach of hand-rolling and hand-holding individual servers. As with any approach, there are of course some caveats to bear in mind. Disposable resources work best when they are simple identical copies of a workload that don't change during their lifetime. In other words, they don't change or modify any of their own state. So you need to think about how your state is managed. If it's part of the workload itself, in other words, is it accessed on a local disk? Or is the state stored elsewhere, such as in a managed database? If your disposable instances store and manage data, the data disks themselves can be managed separately from the disposable element of the instance. We'll get into the details of this in a moment. Environment-specific configuration should also be separated from a deployment artifact, so that you can maintain parity as you promote releases from development to staging and finally to production. This can be done by using the same machine image and retrieving environment-specific configuration from a metadata server at boot time. So always consider whether your workload is stateless or stateful when making your design decisions.